Okay, so here's one of those examples I left off that we just did in class. It's with circumscribed polygons, and basically they all amount back to that theorem, theorem 1011, the kind of the Duns-Cap theorem, and that is if two segments are tangent to a circle and they meet at a point outside, those segments are the same length. So um, I know this and this are congruent. I know these two segments are congruent. I know these two segments are congruent. And I know that these two segments are congruent. In fact, they're congruent to the pink as well, but I'm going to call them something separate. Okay. So I know that's those guys are all congruent. So that means if this is 3 here, SD is 3. If this is 3, CB or CR is 3. Now you might say to yourself, well, how's that helpful? Well, I also know this is X and this is X. So all of those sides together, X plus X plus X plus X, so the 4 X's, plus 3 plus 3, plus 3 plus 3, has to equal the perimeter, which is 18. So you got 4x plus 12 is 18. Subtract 12. Is that right? Yeah, 4x plus, yeah, 12. Then divide by 4. X is 3 halves, or 1.5. Let's make that look like 1.5. There we go. Okay, so first example. All right, next example of something we went over in class. Determining whether or not these circles are tangent, and then justify your answer. 13 is actually pretty easy to justify quickly, because it is. Um, this is a right angle. It's perpendicular to it, meaning it is tangent. But the reason I know it's so quickly a right angle is this is a Pythagorean triple, 7, 24, 25. So yes, perpendicular to YZ. I know that because it's a right triangle. Now I have to do the same thing with number 14. I have to see, is this guy a right triangle? Now we have to remember, just like on the example in the notes, this is 6 and this is also 6. So this whole thing is 10. So our guess is 6 squared plus 8 squared equal to 10 squared. And the answer is yes again, because one, you can check it out and you get 100 equals 100. Or this is really a 3, 4, 5. So yes, perpendicular to YZ. That was a nice and straightforward one. Okay. 20 is asking us to solve for x. Now this one is not so nice and straightforward. In fact, it's actually quite difficult compared to some other problems. First, I have to assume it's a right angle. Okay. RS is x. Okay. And then this guy here is actually x plus 12. So the quantity x plus 12 squared equals x squared plus 20 squared. And the issue is that when I square x plus 12, the quantity squared, I have to go back to some old Algebra 1, good old FOIL. Okay, so x plus 12 times x plus 12 is the first times the first, that's the f part, which is x squared. And then the outside is x times 12, which is 12x. The inside is 12 times x, which is 12x. And the last is 12 times 12, which is 144. Okay. So you get x squared plus 24x plus 144. That's what that left side equals to. And then 20 squared is 400. Now you might be going, ugh, how am I going to solve this? Well, there's actually something that happens that's really nice. And that is the fact that once you subtract an x squared to try to move it, it actually cancels both of them off. So the book isn't that ridiculous. They kind of cut you some slack. So then we really get 24x plus 144 equals 400. Subtract 144. 24x is 256. I don't think that divides. Yeah, it's 10 and 2/3. Okay. So there we go. 10 and 2/3. Okay, last example to take a look at then. Here's 26. And this one probably seems, well, if you're forced to guess, you would probably guess what to do, but at first glance, it looks probably a lot more complicated than it really is. I'm trying to solve for x in this problem. And the problem is these two guys are on different circles. But this segment is tangent to this circle, and so is this ray, meaning this segment's congruent to this one. And then TR and TS are both tangent to circle B, so that means those guys are both congruent. So really all three of those segments are congruent. So 3x minus 8 has to equal x plus 10. So subtract an x, add an 8, 2x equals 18, divide by 2, x is 9. Okay, and those are some problems from section 10.5.